Dear students, good evening to all of you. Congratulations on successfully completing the ESE Engineering Exam Paper 1 and 2. We wholeheartedly feel that all of you have written the exam very well. Definitely, because of the hard work you have put up, the results will come in a positive manner. If not this year, it will definitely come in near future. Hard work is always going to pay off. In spite of all the efforts, there is a chance that we may not get the results according to our wish. These things we can sort it out. So in this evening, we all professors are here to discuss and analyze the ESE Engineering Exam Paper number 2 and give the solutions for them. This year, the question paper is little tricky. The questions are given, some of them directly, but some of them, if you know the concept well, we can get to the answer easily. And of course, some of them are little lengthy in getting the solution. Obviously, as it is a relative measure, whoever is going to do well, and he is going to succeed in the examination. So, in this regard, we are ready with all the solutions. Let me start, first of all, the subject digital and microprocessor. And then after some time, I come up with computer organization. The questions given on digital and microprocessor this year, you can see here. Yeah. So, analog and digital electronics, last year 17 questions have come, and this time it is totally 30 number of questions. Okay, right. So, similarly, in computer organization, last year 12 questions have come, and this year 10 questions have come. Let us see how these questions have come on digital and microprocessor as well as computer organization. First, I will complete the questions on digital and microprocessor. What is analysis for that and what is the solution for that? And also, final answer I am going to give it. Let me start. So look at this question, and the solution is very simple. In order to AND with immediate value, always the answer is going to be AND immediate. So such a simple question also has come in this examination. Correct answer is C. Let's go to the next question. The arrangement of minimum number of n flip-flops can be used for any counter. So I think most of the times while we are designing the counter, we will see this relation. 2 power n should be greater than or equal to modulus of the counter. So the modulus 2 power n should be greater than or equal to this. That means in reverse, the modulus should be less than or equal to 2 power n. So the correct answer to this is modulus should be less than or equal to 2 power n. At the same time, it should be greater than or equal to 2 power n minus 1 plus 1. The correct answer to this is B. As you can see, these are all straightforward statements. If you know the concept well, even though you don't know it completely, we can deduce the correct answer from the known concept. Okay, something like this. Start from here and come up with the correct answer to this. Fine. This is little unexpected question. We know the CMOS voltage levels, but he is asking about one of the particular logic family. So that is the difficulty in engineering service examination. CMOS 4000 is one of the logic family. So for this logic family, which is the correct one in this one here. So he has given supply voltage, propagation delay, worst case noise margin, and PSE, that is speed power product. To answer to this question, we need to have little presence of mind. Okay, so we know that CMOS compared to BJT version, BJT logic family, it will have less power dissipation, more noise margin, more fan out. Like this, you need to recollect it. Okay, for CMOS one, the voltage levels will be from 3 to 15 volts. That means you can eliminate answer A and B. You can eliminate answer A and B. These are not going to be correct. So answer should be either C or D. That's it. Now coming to the next one, you know that its noise margin is 1.5 volts. If you see any CMOS logic family, its noise margin is 1.5 volts. So the voltage supply is 3 to 15 volts and noise margin is 1.5 volts. Hence, the C is the correct answer to this. So answer is C. That's it. That's what I always tell. For some questions, you may not know the complete answer, but you may be knowing some part of that answer. So looking at that part of the answer, you must be able to obtain the complete answer in this type of analysis. You go for elimination process. You have to go for elimination process. Let's move on to the next question. The content in the flag register 8085 microprocessor is read by push PSW and followed by pop instruction. So next one is the content in the flag register in 8085 processor is not able to read and write, read and store to any general purpose register. I think it's a very well known fact. The flag register, we cannot move it to accumulator, we cannot move it to B register, we cannot move it to C register. So the only way to get the flag register value into general purpose register is push the PSW into stack memory and pop it into some HL register or BC register or DE register. So both of them are true and second one is explanation for the first one. I repeat, statement 1 is correct, statement 2 is correct and statement 2 is the explanation for statement 1. That's the reason the answer is A. So here you need to be little careful choosing between A and B. Choosing between A and B. So here both statements are correct and then second one is the explanation for the first one. Hence A is the correct answer. Now let's come to the 14th one. The setup time and hold time. So when you are studying about the flip-flop characteristics, we clearly tell about what is the meaning of setup time, hold time, worst case propagation delay, contamination propagation delay, so many things we hear about it. I think he has given a question based on that. So if setup time and hold time are met, then the D input is passed on to the output. The D input is passed on to the output. That is correct. Next one. He has given what is the meaning of setup time, which is nothing but input should come before the clock input. Similarly, he has explained hold time, that is input should be constant after the clock edge. Input should be constant after the clock edge. Hence, this statement is also correct. But this one is not the correct explanation for the first one. Hence, answer is B. That is, statement 1 is correct, statement 2 is correct, but 2 is not the explanation for statement number 1. Hence, answer is B. Okay, so what is the maximum conversion time of counting type ADC? So we always study about different types of ADC. In that, the first one is counting type ADC converter. So the conversion time is equal to 2 power n minus 1 cycles. 2 power n minus 1 cycles. So the correct answer to this is B. Let's move on to the next question. Yes, it is a 4-line to 2-line priority encoder. So we solve a problem also based on this. I always tell in the class, you need to remember this one. It is a 4 input and this is 2 output. These inputs are D3, D2, D1, D0. Outputs are AB. Okay, what's the output he has given? Okay, X and Y. So this is X and this is Y. So I always tell you to remember these expressions. Expression for X is D3 plus D2. expression for Y is D3 plus D2 bar D1. That's it. So which one is going to match with this one? You can see the answer is A. The answer to this is A. Yeah, these are all straightforward questions. Don't waste time by going for again putting a table, taking a K-map and solving it. Why? Because these are the relations which are to be remembered, Yeah. Next one is how many flip-flops are required to build a counter? It should count from 0 to 4095. That means the total number of counts are 4096 inclusive of 0. For this, the number of flip-flops can be found out by using this relation. So 12 flip-flops is the correct answer. Answer is equal to C. It is straightforward. Let's move on to the next one. Yeah, a 2-bit binary multiplier can be implemented using, that's what I'm saying. For all these things, you can't start designing the system in the exam. You have to remember some of the things. In the class, I used to tell, when you want to go for 2-bit multiplier, we require 2 off-adders and 4 AND gates. 2 off-adders and 4 AND gates, this is the point to be remembered. Correct answer to this is, so here 2 off-adders and 4 numbers of 2 input AND gate. Answer is B. You can't keep designing the system in the exam, okay? So it should be remembered some of the things, and we always stress in the class, please remember these points. One more easy thing here, for a off subtractor, what is the output expression? Off subtractor, output expression. We always know that the difference output is equal to A XOR B, and the borrow output is equal to A bar B. That's it. So A XOR B is nothing but A bar B plus A B bar. So this is the difference expression. So the difference is D and borrow is X. So instead of B here, he has given X. So which solution matches with this? You can see here D is A bar B plus A B bar and X equal to A bar B. The answer is C. So you have to save your time here and use this time for solving difficult problems. Okay? Yes. Which one of the following statement is correct? You know, there are bipolar logic family is there and CMOS logic family is there. Okay, between them, bipolar is the fastest. Bipolar is the fastest one. Okay, let's read it one by one. ECL has the least propagation delay because it is a non-saturated logic. ECL is having the least propagation delay. This one is correct. The reason for this is it is a non-saturated logic. Next, TTL has the least propagation delay. Wrong. CMOS has the highest power dissipation. The very much advantage of CMOS logic family is its power dissipation is very, very less. Its package density is very high. Okay, so that's the reason it is wrong. TTL has the lowest power consumption. No. Compared to TTL, the other thing, CMOS, it's going to take the lowest consumption. That's the reason this is wrong. So the correct answer to this is A. That's it. So you can see all these questions are straightforward. Yeah, static random access memory contains. These are all 1-bit answers, 1-sentence answers. So we require 6 MOSFET transistors, 6 MOSFETs in order to construct this one. The correct answer is A. Okay? Yeah, going ahead to the next one. It is based on 8085 microprocessor. So if I do this, what is the value of stack pointer and HL register pair? That's what he has given. What is the value of stack pointer? HL. So it requires little bit of presence of mind. I'll tell you, LXI HP 27FF, that means SP is going to have 27FF. Then it is having call instruction and pop instruction. Please remember, call is going to have the push operation and pop is the next instruction. So this contains push operation, this contains pop operation. For push, the stack pointer is decremented by 2. For pop, the stack pointer is incremented by 2. That means stack pointer value will be same as initial value. It is not going to change. And then, if I say pop H, top of the stack values comes to HL pair. Top of the stack values comes to HL pair. So from the stack memory, it comes to HL. What are the top of the stack is, when I say call, next instruction address 1006, is this goes to top of the stack. So 1006 goes to the top of the stack, and then from the top of the stack, it comes to HL. That's the reason HL value is going to become 1006. This is the correct answer to this. So SP is 27FF, HL is 1000HH. So the correct answer is C here. In fact, this is the previous year question, okay? Around 3-4 years back, the same question has appeared in the engineering service examination. Yes, the next one is, what are the total number of memory access required for this particular instruction? You know that instruction cycle consists of fetch cycle and execution cycle. So for this instruction, it is a 3-byte instruction. LDA 2003 is 3-byte instruction. 3-byte instruction. That's the reason in the fetch cycle, we require 3 memory access. And then, in order to load the value into accumulator, it requires 1 memory access. So, the total number of memory access is equal to 3 plus 1, that is 4. Answer is D. In that manner, you have to analyze what is the meaning of instruction cycle and come up with fetch cycle and execution cycle explanation. From that, you will come to know how many memory access are there in this instruction. Let's move on to the next one. Yes. Okay. So he told that here A is equal to 89H and B is equal to something like 3CH. A minus B we need to perform. For this problem, all the options are wrong. You are supposed to get the answer as 4D. Answer is 4D. So in the given options, nowhere the result is equal to accumulator, equal to 4D. So the options are wrong here. Right? So we'll see how they are going to deal with this. This question options are incorrect. Let's look at the next one here. So 8085 processor, A is initially 05 and then B is equal to 05. So the correct answer to this comes as something like 17. Let's do it how it is. B is 05, add B. So initially B is added here and then the B value is decremented. It is going to become 5 minus 1, 04H. So as it is not equal to 0, again it comes up. Add B. Now the latest value of B is equal to 04H. So now B is again decremented. 4 minus 1, 3. Next, add 3 here. Now B value is 3 minus 1, 2. Add 2 here. It is going to become B equal to 2 minus 1, 1. Add 1 here. Then B equal to 1 minus 1, 0. It is going to come out of the loop. Out of loop. Yes. If you do this, how much it comes? Look at this. 10, 14, 17, 19, 20 decimal. That is going to become 14H. To this, I am adding 03. After coming out of the loop, I am adding 03. So this is 17H. So the correct answer to this question is equal to A. Right? 17H. So this is what you need to see carefully. The B value is keeping on changing. Right? This is also previous year question only. Fine. So which one of the following? I think it's very simple. It is nothing but direct memory access. Okay? So it is going to transfer between two memory mapped devices without the intervention of CPU or the use of main memory. So this is nothing but it is going to be called as direct memory access. Answer is C. Okay. Fine. This is a very simple one again. What is the quotient and reminder after doing this? Best thing is convert each one of them into decimal. X is equal to 32 decimal and D is equal to 6 decimal. So divide 32 by 6. 6 5s are 30. The answer is 2. So that means the quotient is 5 decimal, which is 0101, and the remainder is 2 decimal, that is equal to 0010. So wherever it matches, that's the correct answer. Correct answer is A. Right? Yes. So this looks like lengthy, but all of them are simple ones here. So which one of the following is a drawback of programmed I/O? Whenever we discuss about programmed and interrupt driven I/O, in programmed I/O, CPU time is going to get wasted. CPU time is going to get wasted. And whenever interrupt driven I/O comes, CPU has to execute many instructions, because whenever interrupt comes, it has to initialize some of the registers. Some of the registers it has to push it into the stack memory. So many options you have to take up. So the correct answer to this is A. Processor is tied up in managing an I/O transfer, and number of instructions must be executed in interrupt driven I/O. So these are the two straightforward drawbacks of programmed I/O and interrupt driven I/O. That's it. So these are all the questions on digital and microprocessor. Now I invite my friend Narasimha to discuss the questions on signals and systems. Thank you.
Thank you, Dr. Chakrabarty sir. Hello friends, hope you have done well in the exam. This year we got 4 to 5 questions from signals. few models are very tough. It is not actually ESE objective model. Let us see the models which we got. What is the Laplace of this periodic waveform? We know the standard relation. Xp of s equals to, taking for one period, the Laplace of original waveform divided by 1 minus e power. Here a value is mentioned as 1. The fixed time period for this signal is 2 seconds. You should write the mathematical expression for one cycle from 0 to 2. A is mentioned as 1 for us. That will be like ut minus 2 into u of t minus 1 plus u of t minus 2. Of course, when you write the Laplace of that one directly, 1 minus 2 e power minus s plus e power minus 2s by s. Fixed one denominator 1 minus e power. Numerator can be written as 1 minus e power minus s whole square. Denominator is s into 1 minus s into 1 plus e power minus s. Okay? Cancellation of the terms. Cancellation of the terms. Further, if you take here the common terms 1 minus e power minus s by 1 plus e power minus s. Take e power minus s by 2 common in the numerator. Similarly, e power minus s by 2 common in the denominator also. That will make option A. That will make option A. Straightforward model, Laplace of switched periodic wave. Let us see the next question that was asked in the exam. This is Fourier series model. Fourier series question. Square wave. Normally square wave with DC or without DC we can take, you are aware, something like this. If you remove the DC, it will have only odd harmonics. So P is related to triangular wave because the Fourier series coefficient for a triangle generally proportional to 1 by n square less number of harmonics. So R is related to 3. So based on that, which is a valid option for us? 38. Yeah, very simple model. Okay. Let us see the next model that is asked. Regarding Butterworth filter, the question is framed. Of course, maybe our options are missing here. What we need? What we need means Butterworth filter characteristics will be, we know maximally flat response both in passband and stopband. Passband, stopband gain will be given. Ohm P, ohm S will be given. Based on the given specifications, we are in a position to find out the order. Del F is the transition width. According to the options given, the pairing is B. You have to do that pairing. N and del F, they are fixed means we have chance of getting the complete design. Once we know the order, N and del, we have chance of getting this. Like that, according to the pairing that is given, it will come under option B. Okay? See this question. An analog signal with bandwidth of 6 kHz. We wish to calculate the 2 power m point DFT for that. Resolution means spectral spacing. Del F must be less than or equals to 200 Hz. Bandwidth 2 kHz means Fs is 2 times B. That becomes how much? 12 kHz. Del F is Fs by N. Del F is Fs by N. So when you solve for N here, 12,000 by 200, that becomes how much? 60 or not? 60. 2 power m style means actually we should take the nearest power as 2 power 6. Nearest power as 2 power 6. But he is asking what is the minimum length of analog signal to be recorded. What is the minimum length of the analog signal to be recorded means T0 is N by Fs. But according to the given option, he has chosen same N number, 60 divided by, what is Fs here? 12,000. That is indirectly 1 by 200. How much? 0.005 seconds. 0.005 seconds. Okay? Means option C. This question, slightly varietily given. It's not that much easy to solve, especially in ESE objective. The jet transform of a causal LTI system is given. The poles are located at 2 and 2.5 when you solve. 2 plus 2.5, 4.5, that product becomes 5. But output is given as sum of right and left side sequence. Based on that, output ROC you can say as 0.5 less than mod z less than 1, because this is mod z greater than 0.5 right side sequence, this is mod z less than 1. As the word causal LTI system is given, which is the largest pole, mod z greater than 2.5, that is for Hz, transfer function 2.5. We learn R1 intersection R2 if there is no pole 0 cancellation. He is expecting about the input. As the output has ROC of 0.5 to 1, as the ROC output is 0.5 to 1 and mod z less than 1 indicates left side sequence, the choice is between B or D. But I am discouraging this particular question. Don't take me in wrong way. Solving this question in the exam is not easy. If you think of ROC, choice is between B and D, maybe the option is also printing error. That is what I felt. Okay. So these are the few models we got, slightly variety models we got. Thank you. Next, Professor JNR sir will come to deal with control subject.
My name is J. Nageswarrao. I am going to discuss the control system questions. So this question, they are asking the settling time for plus or minus 5% tolerance band. For plus or minus 5%, Ts equal to 3 tau or 3 by zeta omega n. So here 2 zeta omega n given 4. So, 2 zeta omega n given 8. So zeta omega n equal to 4. So that means Ts equal to 3 by 4 seconds. So answer B. Next, this is given a step response of second order system. Directly we can represent the pole location, directly we can find the transfer function. So here if I observe, exponential power is real part, that is minus 1. And this cos or sine function become imaginary part, that is j root 3. So this diagonal length is called omega n. Omega n equal to root of 1 plus root 3 square become 3, that means 2. And this is called theta. Zeta equal to cos theta. So that equal to 1 by 2. That means 0.5. If you observe the options, omega n square 4 and option D is correct. So zeta also here will get the 0.5. Next, here given a second order system as well as step input is given. Is asking 94% of the steady state value. 94% is approximately 5% tolerance band. For plus or minus 5% tolerance band, Ts equal to 3 tau. So here pole location is minus 1. So that means time constant is 1 second. So that means approximately 3 seconds. It should be less than 3 seconds because it is not a 5%. More than 5% means it should be less than 3 seconds. Less than 3 seconds means option B is correct. Non-minimum phase system. In non-minimum phase system, there should be a H0 in the right of S plane. So that means answer A is correct. A system has poles. So this is a direct question from our material. So here he is asking the frequency phase at the below the what 20 Hz is asking. Below 20 Hz we are having 2 poles. So that means 2 poles we are having below 20 Hz, 0.01 Hz and 1 Hz is the below 20 Hz, and there is a 1 0 that is 5 Hz. So that means 1 0 So that means one pole, the phase angle should be minus 90 degrees. So answer is A. Next here, magnitude response is given. So at omega equal to 0, the magnitude is given 5. The magnitude is given 5 and is given, MR given 10 by root 3. MR is given 10 by root 3 and omega are given 5 root 2 radians per second. So it is a direct question, it is a question from notebook itself. So we will get zeta 0.5. If you solve it, zeta 0.5 you will get it. Omega n you will get the 10. So 10 radians per second. If you write the answer, you will get k into omega n square means 500 divided by s square plus 10s plus 100 you will get. But no option matches. Here it should be 10. Then the option C is correct. Next it is a direct formula, MR formula. So 1 by 2 zeta root of 1 minus zeta square is the answer. Next here they are asking the phase margin they are asking. First you have to find phase margin formula is 180 plus angle of GH of j omega at omega GC. First find omega GC. At omega GC magnitude 1. So that is 2 root 3 divided by omega root of omega square plus 1 equal to 1. You solve it for omega GC. You will get omega GC root 3 radians per second. Then find the phase margin. Phase margin equal to 180 minus angle GH is 90 minus tan inverse of omega GC means root 3. You solve this, you will get the 30 degrees. Phase margin is 30 degrees. Answer C. So this is a stable system. So you will get phase margin is infinity. So you solve it, you will get omega GC does not exist. So similar to the last question you solve, omega GC does not exist and it is 100% stable system. Closed loop system stable, the phase margin becomes the what? Infinity. So the transfer function for the tachometer. Tachometer is a derivative controller. So it is a simply KTS. So here asking open loop DC gain. This is a closed loop transfer function. Convert into open loop transfer function. So because we want open loop DC gain. What is the open loop transfer function? Subtract the numerator term in the denominator. That means s plus 4 divided by s square. If you have subtract s here, it will become 6s plus 9. So DC gain means frequency 0 if you substitute. Then the answer is 4 by 9. So the answer is D. So here he is asking for second peak, what is the peak time they are asking? Peak time for second peak. So what is the formula? For second peak is 3 pi by omega d. 3 pi by omega d seconds. So find omega d. So omega d equal to omega n root of 1 minus zeta square. So if you solve it, omega n 5 root of 1 minus zeta square means zeta here. Zeta it will become 0.8. 0.8 square. You solve it, you will get 3. So Tp equal to, so 3 pi by 3. So the answer is pi. So that means answer is D. Next, this is a Nyquist contour. States that an amplifier is unstable if the Nyquist can't enclose -1. If you enclose S -1, it is going to become unstable. And amplifier is stable if the curve does not enclose. If it does not enclose, it is stable. It is correct if the answer be 1 plus A beta should be less than 1. A beta should be less than 1, then it is going to become stable. So answer B is correct. That's all. Next analog circuits will continue.
next question. The statement 1. The differential amplifier is said to be operate in common mode configuration. Common mode means when both signals are given same to the differential amplifier or op-amp. So the differential amplifier is used to operate in a common mode configuration when same voltage is applied to both the terminals. So statement 1 is correct. Whereas the ability of the differential amplifier to accept the common mode differential gain, common mode signal is defined as the figure of merit. Figure of merit is what is that? CMRR only. Now what is CMRR? The common mode rejection ratio. The ability of the op-amp to reject the common mode signal output. So not to accept, this is to reject only. So that the statement 2 is wrong. So statement 1 is correct, statement 2 is wrong. So your answer is C. Coming to the next question. By considering the standard notations, the time period of linear ramp generator. Linear ramp generator using 555 timer circuit. So generally monostable, astable we are going to study, but here linear ramp generator is given. For this it is a standard formula. So option C will be the correct one only. So coming to the next question. By considering the standard notations in the VCO, the center frequency is, the frequency of oscillation generated by this one is, so whenever the VCO you are considered, voltage across the capacitor flips between VCC by 4 and VCC by 2. Now this is 0, this is T by 2. Now by considering C ratio is dV by dt. So I by C is equal to dV is how much? Difference between these two. So it is VCC by 4 and T by 2. So you will get VCC by 2T. This is nothing but VCC by 2 into F. But where I is VCC minus VC by R only. So that VCC minus VC by RC is equal to VCC by 2 into F. So the frequency of oscillations is 2 into VCC minus VC by RC into VCC. Here VCC is nothing but positive supply voltage. So to V plus minus VC is the modulating signal. So that option D is the correct one. That is center frequency generated by your VCO. Coming to the next question. In reduction in noise and nonlinear distortion, the additional stages are used to bring the overall gain up to the level. So generally the noise and nonlinear distances can be reduced only with the help of positive, with the feedback only. So with the feedback means option B and option D. But whenever you are designed to reduce that, so 1 plus beta A must be very high only. Whenever it is very high only, you are going to get less distortion, less noise. So beta value must be more, so that more noise and introduce as much as noise back into the system that reduced by the feedback amplifier. So option D is the correct one only. So coming to the next question. In op-amp, the effect of asymmetries between the internal circuit driven by the inputs can be reduced by. So the asymmetric between the internal circuits can be reduced only by connecting a potentiometer at negative power supply. So this is connecting a slider of potentiometer at this one. So option D is the correct one only. So next. The networks can be continued by Hanumantrao sir.
Guys, this is Hanumantrao Network faculty. All the best for all the aspirants, those who are attempted for ESE examination. Now let me consider that the network questions. This year more number of questions are, nearly 18 questions are there, guys. Now let me take one by one. The first one is 16th one. Here the simple one, if you take that star to delta conversion, definitely you will get that here. By making that star to delta conversion, it's a simple one. I think option A is the correct one, right? By making the delta to star to delta, it's a very simple one. I need not explain about this. Option A is the correct one, right? Let me take the next one. This is under graph theory. What is the value of the number of possible trees for the graph? Now, guys, you are having the direct formula for number of trees. You know that if the given tree is the complete tree, you know the number of trees or n power n minus 2, you are getting that where n is the number of nodes here, 4 power 4 minus 2, which is equal to 16. Option B is the correct one, right? Now the next example. This is also under graph theory. Which one of the following is the fundamental cut set of the graph shown in figure? Now, if you take that the fundamental, here he wants to take that the graph is this one, the tree fundamental. What we are getting that the fundamental cut set he wants. Fundamental cut sets, you can take it here, the fundamental cut set as, this is the fundamental cut set, 1, 2, 4 is the fundamental cut sets, you can take it. Option A is the correct one, right? Now the next question is, see this one, this is for the network shown in the figure, which is closed at t equal to 0. The condition was given here. General condition for r by 2l is less than 1 by root LC. You know that, you all know that whenever r by 2l is less than 1 by root LC, then roots are complex and conjugate, then the response is operating under damped condition. Option C is the correct one, right? Now the next one is, guys, here the similar question is given, how the response, whether it is overdamped and underdamped. Here only the simple calculations, we need to check it that, what value we need to check it that r by 2l and 1 by root LC. What we are getting that r by 2l means 2 by 2 into 2, here we are getting that 1 by root LC means 1 by 2 into 2. That means what we are getting that here 1 is greater than 1 by 2, then you are getting that response is overdamped. Very simple questions here, you can take it. Now see this one, this is the only the question which you can, you need to spend some more time regarding that here Laplace transformation. First you need to do for this question the source transformation technique, and after that we need to apply the Laplace transformation. By using the Laplace transformation by KVL, nothing but what, by KVL you can get it, because you are going to get the one simple loop. Then after that by VDR, by voltage division rule, you have to define that V naught of S. That V naught of S you will get in terms of the source voltage. Once you solve the entire in terms of the Laplace transformation, finally you will get V naught of S. After getting that V naught of S, then definitely we should go for the inverse Laplace. If you take that inverse Laplace, are you getting that? First make the source transformation here, and first apply the Laplace, then make the source transformation, then apply the VDR voltage division principle to obtain the value of V naught of S, then get the V naught of S, then make the inverse Laplace, then get the V naught of t. Finally, you will get that V naught of t is B. V naught of t is B is the correct option. Let me consider the next example. Guys, this is under transient circuit analysis. For the network shown, which is moved from position A to B. According to the here positions, you are able to take it from A to B. Suppose in the first position is at A, then definitely capacitor is affecting with that. With that you can get it the initial value of that. The initial value you can take it that voltage across 2 ohms, capacitor is open circuit, 4 and 2 are connected in series, then open circuit voltage is 2 volts you are getting. Since total voltage is 6, total resistance is 6, then voltage across 2 ohms resistor is 2 volts you are getting. That is the initial voltage. Then after t equal to 0, the switch position is at 2. Then you know that the network is going to be the source free circuit. For source free circuit, voltage is the energy storage element. That voltage across a capacitor is similar to voltage is across 2 ohms resistor. That's why you are having a direct formula Vc of t is equal to V naught into u to the power minus t by tau. Here the calculation part is tau. That one also you need not go for any calculation part. By looking into the circuit, I can take it the separable point is here. Under that instant 4 and 2 and these 2 are connected, both are in parallel. 6 and 2 are connected parallel. R equivalent value is equal to 6 into 2 by 6 plus 2. With that final answer, you will get it by using the time constant V of t, which is voltage across the 2 ohms resistor, which is same as, this is very important here. He asked that voltage across the resistance, but we are finding that voltage across the resistance is same as the voltage across the capacitor, since both are connected in parallel. That's why Vc of t or V of t is equal to 2 into e to the power minus 2 by 3. Option A is the correct one. Let me consider the next example. Right. This is the very simple one. Under control system also we can take it. The transfer function V2 of S by V1 of S. Finally you will get that B is the correct option. It's very simple. Now this is the, here somewhat we need to go over the calculation part here. Now the Z parameters are given. Using the Z parameters, how you extract the H parameters? It's a very simple. Here, once you define the Z parameters matrix, nothing but what? V1 is equal to Z11, nothing but 2 times of I1 plus Z12, I2. Next, V2 is equal to what I can take it? Z21, nothing but what? 10 I1 plus 11 I2. These are the equations you have to consider here. Once you obtain that, now define the H parameters. For H parameters, what we are considering that for H parameters, V1 is equal to H11. See this one, H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. If you do that, very simple here, guys, here you need not go for more calculation part. From this, get the value of I2. Once you get the value of I2, V2 by 11, and what I can take it? Minus V2 by 11. And plus V2 by 11 and minus 10 I1 by 11 you are getting. According to this, you can get the values of, see this, from this I can get it 1 by 11 is the H22, minus 10 by 11 is the H21. Using this, I can get it that option A is the correct one. Directly you can take it here. Using this, option A is the correct one. And if you want to get it the rest of the 2 H parameters, you can substitute the value of I2 in the second expression. See this one. This I2, if you substitute in the first expression, this I2, you will get the values of H11 and H12. According to that, option A is the correct one. Right? From the Z parameters to hybrid parameters. Let me consider that next example. This is also very simple here, but here, guys, you should know that what is the lattice network ZA and ZB values. Once you obtain that Z parameters of any network, I can define that lattice network ZA, ZB values. Once you recall that lattice network, how the lattice network will be like this. 4 arms are connected or 4 resistors are connected from input to output. One of the resistor is here. Both the 2 common resistors are not connected each other. I am doing this one as a ZA and this one as a ZB. If you want to express this, this is also ZB, this is also ZA. Why? Because he was given this is the symmetrical network. By looking into this one, this is a symmetrical network, no doubt in that, because it is having from input to output the mirror image. Then ZA value I can take it by knowing the Z parameters. How you know the Z parameters here? See this. How you know the Z parameters? Z parameters can be get it by knowing this one here, 10 into 10 by total 25 you are getting that, 4 you are getting that, 10 into 5 by what we are getting that 25, year 2. With the Z parameters you can get it for T network, it is standard. Then from that I can take it the value of ZA is equal to Z11 into Z12 and ZB is equal to Z11 plus Z12. With this you will get the value of ZA is equal to 2 and ZB is equal to what? 10 you are getting. Then from this, which is the correct option? Option A is the correct one. Guys, in this example, you should know that lattice network ZA and ZB values, how you are able to define in terms of Z parameters. But here, what network is given? Pi network is given. That's why first convert pi in terms of T. That you can easily convert. because for Z parameters, T network is very much comfortable. That's why from the Z parameters, lattice network, ZA, ZB values can be defined like this, right? Now take the next example. The next question is given, what is the Thevenin's equivalent impedance here? I think you know that this is very simple for RTH or for ZTH, because this is the AC, then make it voltage source as a short circuit, then definitely by looking into the A and B terminals, you will get the value as here 12.4 and J 3.4, because these two are connected in parallel, total connected in series with 10 ohms resistor. Definitely, after calculation, once you simplify that, you will get the Z Thevenin's value 12.4 minus J 3.2, right? Now let me take the next example, right? The self-inductances are given and the mutual inductances are given. This is very simple here. The solution, suppose if you want to take it that, here he was given that, you are able to imagine this network here. Once you are able to imagine this network, definitely I can take it here. This is 20 and this is 30 and this is 40. And these two are given, MAB is equal to 8 Henries are given, and this one is given 12 Henries are given, MBC and MAC is given 10 Henries are given. Now with this is the circuit here, and both are aiding, first one, and these two are opposing, this is that one. Now definitely you are able to take that the resultant L equivalent value is equal to separate of this, separate of this, separate of this. Once you add it, I can take it that one directly here, 20 plus 8 and minus 10, 20 plus 8 and minus 10. See this, because both are, these two are aiding, these two are opposing. Next one is what? 30, these two are opposing, minus 12, and these two are opposing, these two are aiding, plus 8. And finally, all are opposing, 40 minus 12 minus 10, you will get it by adding all these. Because all are connected in series, this is the resultant of this one, then definitely you will get option B is the correct one. Option B is the correct one, right? Very simple here, right? Now the next question, let me consider the next question. Right. A coil consisting of 1000 turns, this is given a coil, and the physical dimensions are given here. And a coil, you know that whenever if you take a coil, this is the combination of inductance and resistance, L and R. Here DC voltage applied here. 100 volts DC means for DC, inductor acts as short circuit. That's why he wants to find out that resistance value. And using the resistance value, we need to find out the power for the applied voltage, V square by R. If you do this, here the main thing you need to identify that L effective conductor is equal to number of turns and length of each turn. That is very important. Length of each turn. By doing this, definitely you will get the value here. L R value you will get it according to the given data here. 20 ohms and power is 500 watts you will get it that. Then from this I can say here the option C is the correct one. Option C is the correct one. Now let me consider the next example. Yes, this is also very simple here. The basics which you are having, voltage across the points A and B. Once you travel from A to B, how you have to take it? In this example, first you need to ensure that there is no current is passing through this. Since there is no closed path, here 0 volts. And these all are connected in series. Now total is 30. And here 15 volts is there. According to this current direction is like this, 15 volts here we are getting, because total 30 ohms, 30 volts. Like that here 20 volts, 20 ohms. Then how the current direction? Current direction is like this. From here to here, we are getting the voltage is equal to 10 ohms, 10 volts. Then finally from A to B, if you want to travel from A to B, you should consider the starting terminal 15 plus 5, 20, 20 plus 10. How much? 30 you are getting. Plus 30 you are getting. VAB is equal to plus 30, where we are having plus 30. Option B is the correct. Now let me take the next example. This is also by KCL here. By KCL at V, you are getting the 10 is equal to by KCL. Now the equation I am writing that, with that you can get it VA minus 50 by 5 plus VA by 2. This is very simple here. VA minus 10 by 3. With this you are getting that the VA value is equal to 22.65 plus 22.65 volts you are getting. Option B is the correct one. It's a very simple. Right. The next example, what is the value of the resistance RL in the circuit shown in the figure to deliver the maximum power? You know that maximum power transfer at what value of RL? That means the job is very easy here. If you want to get out only the RL value, now for R Thevenins, definitely RL value is equal to R Thevenins for MPT. Na? Yes or no? For that, I can take it. For RL, we need to make that. For R Thevenins, we need to make this a short circuit. And by taking these two terminals, if you make these two are short circuit, I can take it these two are in parallel, these two are in parallel, and both are in series. That's why R Thevenins for MPT, I can take it RL is equal to R Thevenins is equal to, I can take it 30 plus 30 into 10 by 30 parallel with 10 and total in series with 20 parallel with 40. Okay. Now with this, you will get the answer is, here we are getting that answer value is equal to option, this is 73 now, you are getting that for 73 option B is the 20.83 you will get it, the 20.825 or 827 you will get it, option B is the correct one. At R Thevenins you will get the maximum power transfer from source to load circuit, right? Now take the next example. This is very simple here. He was given that a right angle triangle, now the power factor is equal to cosine of phase angle, adjacent side by hypotenuse, power factor cos phi is equal to what? R by Z. It's very simple. And because it is RL circuit, that is the lagging power factor, R by Z, lagging power factor, right? Now let me consider the next example. Right. A coil consisting of 750 turns and the current of 10 amperes in the coil gives rise to a magnetic flux of 1200 microcoulombs. So what are the inductance value of the coil? The average induced EMF in the coil when this current is reversed in 0.01 second here. This is very important for that one. 0.01 second it is reversed. Nothing but voltage we need to find out that L into di by dt. This dt value is given here. This is 0.01. di value you are getting that reversed. Reversed means what? 10 minus of minus 10. Nothing but what? 20 you are getting that. 20 by 0.01 and you need to multiply with what? Here inductance value according to that L is equal to N square by N5 by I. Using this you can get it here. Inductance value N5 by I. According to that you can get it L value. The L value you will get 0.09. Once you will get 0.09 you will get 180 volts you will get it that. Then the option, which one is option A is the correct one. These are the questions given. 18 questions are given here. You can easily answer within 18 minutes. I think maximum 20 minutes it will take, right? You can complete that. Next, my colleague, analog circuits, Professor Trina sir will continue with this. Okay? Thank you. All the best.
Hi dear students, very good evening. This is MM Trinath. Right now I'm going to discuss about prelims. engineering services prelims of electronics and communication, EDC part, okay, electronic device and circuits. By seeing the circuit questions, by seeing devices questions, yes, I understand they are very easy. Let us go through the first question, very simple question, guys. In a square wave, yes, if you check it out, this question carefully, my dear boys and girls, they have clearly mentioned it is a simple PN junction diode, a germanium diode, or you can consider it is any sort of diode, whereas a square wave is impressed onto the diode, okay. When forward voltage is suddenly reversed to the reverse voltage, okay, square wave indicates what? There is a sudden change, am I right? A positive voltage will be suddenly shifted to the reverse negative side. Negative side must be suddenly shifted to the positive side. So due to that, will my diode experience the change? That is the main intention of this question. Yes, it is impossible. Why? Because every diode is having a charge storage capacitance. Diode is having a depletion layer. Diode is having a charge storage capacitance. Because of charge storage capacitance, yes, there exists reverse recovery time. I believe you can understand this. So this is the graph what I have clearly discussed in the class itself, the current versus time characteristics here. So there is the reverse recovery time. Because of that particular reverse recovery time, the time taken for a diode to enter completely into the reverse bias is the reverse recovery time. Because of that, instantly it never shifts from forward response to the reverse response. So very simple answer for this question. So recovery time is the best option for this. Let me change the color. Yes, recovery time is the option for this. Let me not go extreme detail into that because this is the discussion where you already prepared this engineering services in the coaching. Correct or not, dear students? Let's go to the next question. So, yes, in an open circuited step graded PN junction diode, yes, half part we say it is a P type and the right side is N type. And they have clearly mentioned in this type of doping, that is what is a step graded doping, what could be the potential difference? That is nothing but a built-in voltage. Contact potential or built-in voltage. You can understand in a step-graded diode, the built-in voltage formulae or a contact potential formulae, let me change this here. So it is VBI is equals to, remember or not, dear students, discussed in the class, KT by Q log mod ND NA by Ni square. Of course, natural logarithm. Correct or not, dear student? That's the contact potential. Very simple answer for this given question is KT by Q log mod NDNA by Ni square. How easy this is, guys? If you go through the next question, guys, by considering the standard notations for depletion MOSFET, okay, depletion MOSFET, what must be the lambda? You know that lambda, channel length modulation parameter, correct or not? If it is bipolar junction transistor, lambda represents what? Base width modulation parameter. Whereas in MOSFET, it is a channel length modulation parameter. So as per relation between lambda and early voltage is simply equals to lambda equals to 1 by VA are simply volt inverse. So the answer for this given question is option D, 1 by VA. Channel length modulation parameter. Don't forget, my dear boys and girls, right? I hope you're understanding this. Now go through the next question, guys. The fourth question I understand. The longest wavelength that can be absorbed by silicon, which has the band gap, okay? There is one silicon semiconductor material. Its band gap, they have clearly specified as 1.12 electron volt, fine. And the wavelength, 1.1 micrometers, interesting. And if the longest wavelength that can be absorbed by another semiconductor material of wavelength. So let me say there are two different materials, two different wavelengths. Do one thing, go with this EG1, L1 and lambda 2 they have given as 0.87 micrometers and we are supposed to find the band gap. Let me say EG2 is how much? I think it is very simple question. You know, you must be knowing this formula, right? So energy is equal to h mu, we say hf, correct or not? Energy is equal to h mu, whereas velocity of light, energy with respect to the wavelength, with respect to the frequency is h mu, and velocity of light v equal to f lambda. So if I combine both, so E is equals to simply hc by lambda. If I take h and velocity is maintained constant, then simply energy is inversely proportional to lambda. That's it. Therefore, I could say Eg2 by Eg1 is simply equals to, this is Eg1, right? Eg2 by Eg1 is simply equals to lambda 1 by lambda 2, correct? Because it is inversely proportional. I think you can solve it. I can easily get the value of Eg2. So after solving, I got it as like 1.41 electron volt. 1.41 electron volt. I hope you got the same answer. Our students, right? You're our students. You must be rocking for sure in the exam, right? So 1.416, yes, option A is apt for this given question. 1.416 is an apt. Now let's go through another question, guys. The band gap, the energy band gap of a germanium semiconductor at room temperature. It's very easy. Question, it is simply 0.72 electron volt. 1.21 is for silicon at 0 Kelvin, 1.12 300 Kelvin for silicon, 0.782 0 Kelvin for germanium, 0.72 300 Kelvin for germanium. See, answer for this question is 0.72 electron volt. How easy question paper this is, guys. Interesting. Now let's go with another question. If you go through this question, silicon is doped with boron. You can understand whenever a silicon material, an intrinsic semiconductor material doped with boron, indium, gallium, boron, aluminium, that is p-type, correct or not? So this is strictly representing p-type, correct or not? This is strictly representing what, guys? P-type. So concentration, so they have clearly mentioned acceptor concentration, because when I say the p-type semiconductor, you're supposed to consider acceptor concentration, which is 4 into 10 power 17 per centimeter cube. They have clearly specified. Now assume intrinsic concentration of the material. They have given intrinsic concentration 1.5, that is Ni, 1.5 into 10 power 10 per centimeter cube. So silicon intrinsic concentration at 300 Kelvin, the default value is this one, right? Of course, they have specified in the question. And the value of KT by Q, 25 millivolt, 300 Kelvin, okay. Now compared to undoped silicon, that is compared to intrinsic silicon, the Fermi level of doped, that is very interesting question. Guys, you can understand, if I say the Fermi level, say this is valence band, that is conduction band, and for intrinsic, I could say the Fermi level is exactly at the center, let me say EFI. And it is very clear, the doping is what, guys? P-type semiconductor. In case of P-type semiconductor, you can understand Fermi level will be moving down from intrinsic, moving towards the valence band. So here, I could say this is the Fermi level of P-type semiconductor. Let me say that is the place where we got the Fermi level of P-type semiconductor. So no doubt, compared to the center, the Fermi level is going down. That is for sure. Now what could be the formulae? Because they have given 4 values. Goes up is impossible, correct or not? Let me change the color. Yeah, goes up is impossible, correct? Goes up is impossible. So only we have 2 choices. So goes down by 0.13 or goes down by 0.427. What could be the formulae? Yes, you're right. So intrinsic Fermi level minus Fermi level of P-type is equals to KT log mod Na by Ni. Correct? Yes, this is the formula. KT log mod Na by Ni. So by substituting the values of Na specified in the question, Ni specified in the question, substitute over here, you'll be getting around 0.427 electron volt. So the answer goes down by 0.427 electron volt is apt for this given question. Let's move to next question, guys. So 55th question, you can have a look onto the screen. The resistivity of uniform doped N-type silicon. They have given the resistivity, right? N-type silicon, rho n 0.5 ohm centimeter. Electron mobility, mu n they have specified, guys, 1250 centimeter square per volt second. Correct, yes? And a charge, yes, we know that. The donor impurity concentration, Nd, is how much? Yes, it is. Very easy question, guys. You can understand the concept of drift, N-type semiconductor, because it is donor doping, N-type semiconductor. You know that from N-type semiconductor, sigma n is equals to, almost equals to Nd cube mu n. And of course, this sigma n is nothing but 1 by rho n. That's it. That's it, because conductivity equals to 1 by resistivity. So resistivity they have given, correct or not? So mu n they have given, Nd we need to find, Q, yes, we know that. Can't I solve this, guys? So if I could substitute that and if I could solve, I got it is like 1 into 10 power 16 per centimeter cube. 1 into 10 power 16 per centimeter cube. Then I understand option B is apt for this given question, option B, okay. Let's move to next question, guys. I hope you have done great in the exam, right? You will be rocking for sure. Now anyways, go with the next question, guys. So a silicon sample A, okay, there are two different silicon materials they have provided. Silicon sample A doped with 10 power 18 of boron, indium, gallium, boron, aluminium, yes, it is third group, p-type semiconductor. So Na they have specified, Na 10 power 18 atoms per centimeter cube, fine. Another sample B, okay, next material, identical dimensions, doped with 10 power 18 of phosphorus, arsenic, phosphorus, antimony, bismuth, yes, fifth group elements, right? So this is Nd donor doping, 10 power 18 per centimeter cube. Amazing, guys, right? The ratio of electron to hole mobility, so mobility of electron by mobility of hole, electron to hole mobility. So mu n by mu p, they have given it as a 3. It shows what? Mu p by mu n is simply equals to 1 by 3. Okay, fine. Now we are supposed to find the conductivity of sample A with respect to sample B, that is conductivity of A by conductivity of B. It shows what? Conductivity of acceptor by, I mean to say, conductivity of p-type, I could say, by conductivity of n-type. Correct or not? Because acceptor represents conductivity of p-type semiconductor, donor represents conductivity of n-type semiconductor. It is very easy, guys. What is this formula? Na cube mu p whole divided by Nd cube mu n, right? That's it, completed. Completed, man. Na cube mu p by Nd cube mu n. So Na, Nd, those values are same. I can nullify. Q, I can nullify. So mu p by mu n is simply equals to 1 by 3. That's it. So the answer for the given question is simply 1 by 3. So 1 by 3 is apt for this given answer. Now go with one more question, guys. 57th question. So according to Einstein's relation, you know, once you recollect Einstein's relation, guys, you can understand dn by mu n is equals to dp by mu p is equals to kt by q. Correct or not, dear students? Einstein's relation. So according to Einstein's relation, for any semiconductor, ratio of diffusion constant, yes, diffusion constant by mobility is, what is that relation? So no doubt depends upon the temperature of semiconductor, perfect. It is depending on the temperature, yes, perfect. Depends on type of semiconductor, no man, it is not at all depending on the type of semiconductor, whether it is intrinsic or extrinsic or n-type or p-type. No, this is wrong, right? And where is with lifetime? No, lifetime is nowhere valued over here. Increases with velocity. Where is velocity here? It is just kt by q, the voltage value, right? So the answer for this given question is option A. Option A, right? 58th question. Yeah, go through this question, guys. Go through this question. So a heavily doped n-type semiconductor has the following characteristics. Heavily doped, okay? Wonderful. So hole electron mobility ratio 0.4, hole to electron. That means what? Hole to electron. So mu h by mu n, they have clearly specified as 0.4. And doping concentration, heavily doped n-type indicates Nd they have specified. What is the doping concentration, guys? 4.2 into 10 power 8 per centimeter cube. Okay, fine. Okay, fine. Intrinsic concentration they have given, which is 1.5 into 10 power 4 per centimeter cube. Okay, fine. Intrinsic concentration. Now, the ratio of conductance of n-type semiconductor to that of intrinsic, that is sigma n by sigma I. Conductance of n-type with respect to intrinsic semiconductor at the same temperature. Excuse me, what is conductance of n-type semiconductor, guys? Any idea? Conductance of n-type semiconductor, yes, you're right. This is Nd cube mu n. And for intrinsic concentration of carriers, what is that? Ni q into mu n plus mu p. That's it, completed. Now, a simple suggestion, guys. I know the value for Nd, I know the value for Ni. You please divide with mu n, Then this is nullified, mu p by mu n, substitute that value here. And I believe if you could solve, you'll be getting the value of 2 into 10 power 3, what I got exactly, 2000. So the answer for the given question is 2 into 10 power 3. You can verify the options carefully, my dear students. So yes, one more interesting question we have. A silicon bar is doped with the donor impurities Nd, given the intrinsic carrier concentration, yes, they have given intrinsic carrier concentration, and a complete ionization, okay, impurity ionization. You can understand what is that. For example, if it is n-type, Nd plus is equals to Nd. That is complete ionization. That is the property of complete ionization, as they have clearly specified as n-type semiconductor. Right or wrong, dear students? Now, the equilibrium electrons and hole concentration, very interesting. Equilibrium indicates N naught. What is N naught? N naught is nothing but Nd plus, correct or not? Nd plus is simply equals to Nd. And Nd, they have clearly specified in the question 2.25 into 10 power 15 per centimeter cube. Yes, I got this answer. Concentration of electrons I got. So 2.25. So N naught 1.5. N naught 1.5. This is wrong. N naught 1.5. This is wrong. Wonderful. So N naught 2.25 into 10 power 15, right? N naught 2.25 and 10 power 15, right? So let us move forward, because out of both any one option must be right, right? Now let us go with this question, dears. So we are supposed to find hole concentration also. You know that equilibrium hole concentration P naught. Can I say I can use Ni square by N naught? Mass action law. You're right. According to mass action law, N dot P is equal to Ni square. So what is Ni square here? What is Ni square? 1.5 into 10 power 10 whole square, whole divided by, what is N naught, guys? 2.25 into 10 power 15 per centimeter cube, right? That's it. That's it. I think you guys can easily solve this. If we could solve, you will be getting 1 into 10 power 5 per centimeter cube. That is concentration of holes at equilibrium. So 1 into 10 power 5 per centimeter cube. Yes, 1 into 10 power 5, 1 into 10 power 5. Yes, this is apt. This is apt. Correct or not, dear students? 1 into 10 power 5, 1 into 10 power 5. This is apt. So option D is apt for this given question. Now, yes, one more interesting question we have. Have a look onto the question, guys. So in a physical diode, there is a component of reverse saturation current, okay? So due to the leakage, there exists, okay, fine. The reverse saturation current, we know that the leakage current increases 7% per degree centigrade. That is for sure for both germanium and silicon. Now the relation between temperature and voltage, even though they are given leakage currents, they're asking relation between temperature and voltage. Guys, it is open secret. You know that built-in voltage, I say, ideally diode voltage equals to built-in voltage, ideally, okay. So what is built-in voltage formulae? KT by Q log mod Nd Na by Ni square base E, correct or not? And I believe you know that Ni square depending on T cube. That means if temperature increases, Ni square increases a lot. Ni square depends on T cube. So even though temperature increases, KT by Q increases a minute, whereas Ni square increases a max value because it is depending on T cube times. You can understand that. Therefore, built-in voltage decreases. So if temperature increases, speak out, guys, if temperature increases, no doubt to say built-in voltage decreases. And you know that it is almost minus 2 millivolt per degree centigrade, right? Minus 2 millivolt per degree centigrade. So if temperature increases, voltage decreases. Temperature increases, voltage decreases. Surprisingly, option A and B, they have given the same data. So any option, either A or B or both, okay, you can choose for this given question. Wow, these are the questions, what I understand from electronic devices and circuits, guys. So I believe you rocked in the exam. So wish you best wishes from my side. Have a great success in your life.
Start. Right. So let us see some questions given in communications and advanced communication. Let us see this question. Here he is talking about VSB. Popular method for generating VSB modulated wave is to use frequency discrimination. Frequency discrimination is nothing but using filters. So whatever he is saying is correct in the first statement. And in VSB we transmit one sideband and a small part of the other sideband. And the sideband that we are completely transmitting is also suppressed a little bit. So whatever the statement he is giving in the second one is also correct. And this is obtained by using filtering operation by filter only. So I think the correct option would be option A. Both the statements are correct and second one is a correct explanation for first statement. Let us see the next one. This is also assertion reasoning only. So during the sampling and quantization process, because you round off the sampled signal amplitudes to some predefined values, you cannot reconstruct the complete signal as it is. But here he is saying you can reproduce an exact replica of the original analog signal, which is not possible. So this statement is definitely false. And use of digital communication offers good flexibility and compatibility. So all these are related with the digital communication techniques, which is definitely true. So first statement is false, but the second statement is true. So your option would be B. Okay? Two assertion reasoning questions, fundamental questions only. Now let us see the next one. The power transmitted by an SSB is 20 kilowatt, required to be replaced by a standard AM having a modulation index of 0.4. What is the transmission efficiency? So directly you can use the formula of mu square by 2 plus mu square, single tone signal. So if you substitute this 0.16 divided by 2.16 in percentage, so multiply it with 100. So you will be getting around 7.45%. So your correct choice would be option C. Done. Next. An angle modulated signal is given. He is asking instantaneous frequency. So what is the instantaneous frequency? Fi of t. This will be 1 by 2 pi into first order derivative of instantaneous phase, which is nothing but 200 pi t plus pi by 4. So when you take the derivative and divide the result with 2 pi, you will get 200 pi by 2 pi, which will be equal to 100 hertz. Straight away formula based question. So your option would be option B. Done. Simple questions, direct formula based. Next, an FM modulator operates with this, the data is given, he is asking you the relation based on modulation index. See this, what is the relation between frequency modulation index and phase modulation index? So frequency modulation index is beta in FM. This is nothing but KF into AM divided by FM. And modulation index in case of phase modulation is simply KP into AM. So if you substitute the parameters that are given here and check the relation that you are getting here is beta in PM is 5 times the value of beta that you are getting in FM. So your correct option would be option D. Direct substitution, formula substitutions only. Next, what is the relationship between the percentage efficiency saving when the carrier wave and one of the sidebands are suppressed in an AM wave modulated to a depth of 100% modulation? So if you take modulation index or modulation efficiency in case of standard single tone modulation AM, this value with mu equal to 1 comes out to be 1 by 3. Okay, and second thing what he is saying is he is suppressing one sideband and percentage efficiency saving on the carrier wave and one of the sidebands are suppressed. That means he is doing a transmission of only one sideband. So basically modulation efficiency in that case would be equal to 1. So when you take the relationship between modulation efficiency of these two things, either it should be 3 because here your efficiency is 1 by 3, power efficiency or modulation efficiency. If you suppress carrier component and even if you suppress one of the sideband, power efficiency would be equal to 1 only because you are transmitting only the sideband which is carrying the information. So obviously the power that you are saving should be actually 3, but none of the options are coming in that range. So I think some data in terms of options is missing. Data is something missing in this option. I don't go with any of these case because here also you can see he has given DSB, but actually what he is talking is about SSB. So to be very clear, it should be given as 3, but none of the options is having 3. So it can be the nearest answer that might be option A, but otherwise we cannot go with the correct value. Next, an audio signal phi cos 2000 pi t is quantized using 10-bit PCM. What is the signal to quantization noise ratio? So this value, direct substitution. you know its value is 3 by 2 into 2 power 2n. So if you substitute these values, you will get 3 by 2 into 2 power 20. So this value you convert into normal figures. So this comes out to be 1.57 into 10 power 6. So that will be your correct choice. So it will be option C. Clear? Right. Let's go to the next one. An FM audio signal with single tone modulation, frequency deviation is given, bandwidth is given. What is the frequency of the modulating signal? So you know bandwidth is 2 into delta F max plus 2 into F max. So the value of the bandwidth is given to you as 75 kilohertz is equal to maximum frequency deviation is 20 kilohertz, 25 kilohertz. So this would become 50 into 10 cube plus 2 into maximum frequency of your message signal. So what would be your F max here? 25k divided by 2, 12.5 kilohertz. So your correct choice would be option A, right? So this is completely based on FM modulation index. Next, so here audio signal, he is saying the peak amplitude of the signal can be 1. That means whatever the message signal m of t you are taking, its maximum possible magnitude that you can find is only 1 volt. That is what he has given. And the maximum frequency of the message signal is also given. As per the spectrum, you can take it as 20 kilohertz. And KF value, frequency deviation constant, is given. What is the bandwidth required for transmission? So definitely we are considering it as a wideband FM only. So bandwidth would be 2 into delta F max plus 2 into F max. So 2 into delta F max is KF into AM. KF is 90 kilohertz. AM, peak amplitude of the message signal, is 1 volt plus 2 into F max is 20 kilohertz. So you will have 180 kilohertz plus 40 kilohertz. It will become 220 kilohertz. That is the bandwidth required for transmission of this signal. So I think your correct option is 220 kilohertz, option C. Okay. Both are actually the same model questions given on bandwidth requirements for a wideband FM signal. Next. Now here a collector modulated class C power amplifier is given. Modulated signal power means the total power required to transmit the signal is given as 220 watts. Some efficiency of the amplifier is given, no need to worry about it. What is the power supplied by a modulating amplifier? Means he is asking power taken by your carrier component when the modulation index is mu is 0.4. So you can assume it as single tone signal. Total power is PT equal to PC into 1 plus mu square by 2. Now you substitute these values, you will get that value as 203, approximately 203 point something. So you can go with option C. Okay. Next. By considering standard notations, normalized power of an AM signal. So here standard notations means when you take modulated signal for a standard AM, it will be AC cos 2 pi FCT plus AC KA M of t. You multiply with maximum magnitude of the message signal and divide it with the maximum magnitude of the message signal into cos 2 pi FCT. So when you take this simplification, you will get AC cos 2 pi FCT plus AC, this Ka into peak magnitude of the message signal will be mu, and then you are having M of t divided by mod of M of t max whole multiplied by cos 2 pi FCT. This is the operation you will have. Now if you take the power, first component will be AC square by 2 plus second one will be AC square by 2 into mu square into M square of t divided by mod of M of t max square. These are the terms you will be getting. So this M square of t by mod of M of t max square is nothing but normalized power of the message signal. We generally denote it as PMN. So your actual options should be in this form as per the standard notations: AC square by 2 plus AC square by 2 into mu square into PMN. This is the actual method of writing the total power in terms of normalized power. Now you see your options, Only one that is very much closest to this part will be AC square by 2 plus AC square by 2 into m square of t, assuming that the value of the modulation index he is considering here is 1. I am going for the best possible choice, but actually this will be the total representation. Okay, right. Next. Here it is radiating a power of 125 kilowatt when certain audio signal is modulating with a depth of 70%, means 125 into 10 cube PC into 1 plus 0.7 whole square by 2. And similarly it increases to a value of 144.5 kilowatt. Carrier power does not change. Now the modulation index I am writing as mu t square because he is doing combination of two single tone signals. Now take the ratio of these two things and find the value of mu t square. I think you will be getting here mu t square as 0.878. Now he is asking what is mu2. So mu2 square you can write as mu t square minus mu1 square, and this value of mu2 will be root over 0.3. That's all. Just standard notations. Just use them. Standard formula. You will get your option as B. Okay. Numerical. Straightforward numerical. Next, an audio signal comprising of single sinusoidal signal. He has given a single tone signal quantized using DM. What is the signal to quantization noise ratio? So here the data I think is insufficient because the signal to quantization noise ratio, when you deal with the delta modulator, signal power you can tell it is nothing but 3 by root 2 whole square. RMS value of the signal square 9 by 2 will be 4.5 watts. This is okay. But when you take the quantization noise power in delta modulator, this is given as del square by 3 into value of FM by Fs. FM represents maximum frequency of the message signal. Fs represents the sampling frequency. Now even if you go for Nyquist frequency, you can substitute Fs as 2 into FM, but delta is not specified here. So even if you check for a delta modulator which is operating without any SOD, still we cannot get any values that are given here. So I think none of the options are matching here. None of the options are matching. If we get any other thing, we will update in the final key. Okay. Next. Number of quantization levels is increased from 4 to 64. Means initially 4, number of bits are 2, and then they are increased from 4 to 64. So the number of bits will be 6. So bandwidth depends on n. So number of bits are increasing from 2 to 3, so bandwidth increases by 3 times. But none of the options are matching with this. So this also, I don't think these options are correct. He very clearly asked the bandwidth required for transmission of a PCM signal increases by a factor of dash. It increases by a factor of 3 times. So none of them are actually matching here. Frequency range of broadcast services. So many broadcast services are there, but most of the time we prefer using broadcast services in 2 GHz bands to 4 GHz band. And in an advanced mobile phone systems, AMPS, which of the following separate channels in a link is are used? We use both TDMA and FDMA, time division multiple access and frequency division multiple access. So these are the questions given from communications and advanced communication. Weightage is pretty less in communications this time, and straightforward questions, very easy questions are given. 1 or 2 questions data is not clear and they are not matching with your options. So except that, remaining are pretty clear.
Yeah, let's look at the questions which came from computer organization. So one of them is the third question, which is going to take object file and create either COM file or EXE file. Actual answer for this should be linker, and sometimes linker and loader both are going to be together. That's the reason, as linker is not given, we can take the answer as loader. Okay? So the correct answer for this question is C. Moving ahead. Let's look at the next one. It is the question based on pipelining. We know pretty well. I just tell you what's the definition of pipelining is. A sequential process is divided into sub-process such that each sub-process is carried out in a separate segment in parallel. That is the concept of parallelism and pipelining. So he has given like this. It is going to overlap computer instruction cycles. Yes, multiple instructions will be executed simultaneously. That means instruction cycles are overlapped with each other. First one is true. Second one, it's a definition of pipelining. So why we are going to have the improved performance is because of dividing this into sub-process. So second one is also correct. And in fact, second one is the reason for the first one. So both statements are correct. Statement 2 is the explanation for statement 1. So the correct answer to this is A. Let's move on to the next question. Yes. So which of these is going to be used for transfer between two memory mapped devices without using main memory and CPU? You know that in direct memory access, we can go for data transfer without the use of CPU, maybe between memory and IO devices, between two IO devices, or between two memory devices. So these things are called as direct memory access. So according to the given statement here, the correct answer is direct memory access. The answer for this is C. Let's look at the next one. So this one, already we discussed it as part of this microprocessor. So the first option is the correct answer here. The processor is tied up in the case of programmed IO. That is the drawback of programmed IO. And in interrupt-driven IO, the processor has to execute multiple instructions. So the correct answer to this question is A. Yeah, the next question is this. He has given some instructions, percentage of occurrence, okay, with what percentage it will occur, and then what is the number of cycles per instruction. And then he is asking about, he has given the frequency and 100 instructions, asking about CPI. Out of 100 instructions, you can see this is the denominations. So 38 instructions will take only one cycle, 15 instructions takes 3 cycles, so on and so forth. Then what is asking here is CPI average. So you know very well for a program how to calculate the CPI average. It is equal to 38 into 1, 15 into 3, 42 into 4, plus 5 by 5, 5 into 5, that is divided by total number of instructions, which is equal to 100 instructions. If you add up all these instructions, it comes to 100. So this, if you calculate, it comes to 276 divided by 100. Hence, the CPI average is 2.76. Correct answer to this question is A. So you can see this is very simple if you are fundamentally strong. Yeah, probably the last question based on this computer organization is this. He has told some set associative mapping and then how many number of bits he is using it for main memory. He has given how many blocks are there in main memory, it is in cache memory as well, what is the block size. I think we need not go in depth about set associative mapping, we can answer it in intelligent manner directly. He told main memory is having 4K blocks. Main memory blocks are 4096 blocks. And then the size of the block is equal to 16 words. So This many number of blocks are there. Each block is 16 words. Thus, main memory size is equal to number of memory blocks multiplied by block size. That is 4096 multiplied by 16. This is 2 power 12 into 2 power 4. This is equal to 2 power 16. So this many number of words are there, 2 power 16 words. So he's asking how many address lines we require to address 2 power 16 words. It is nothing but 16. The correct answer for this is D. That's it. So these are all the questions appeared in computer organization. Now I request my colleague Devankit to complete the questions on operating system. Thank you.
So guys, so this is the continuation of OS question. Question number 132. Consider the following reference string pages made by the processor. We have some pages, and now we want to find how many page faults are there if we use LRU scheme. Okay. So even in the question, they have given the frames also. They have given 4 page frames. Number of page frames allocated in the main memory is 4. So let me write here. Let us assume 4 page frames. So we are start from 475, okay? 4, 7, 5. Then again 7 will be there, but it is already present, right? Need not to write. So this is hit actually. So I am just marking it tick. Then 6. 6 is not here. 6 I have to write. Now 7 again already present here. I mark to tick. Okay, so this is a hit actually. Now again for the page number 10. So 10 is not present here. Now I need to check which one to replace. For that we are using LRU, mean from the long time which page has not been used. Okay, so guys, we have to put this 10 from 7, 6, 5, 4. 4 has long back not used. So I am writing here 10. Then 4, then among 10, 7, 6, 5. In place of 5, I am writing here 4. Then 8, we need to write 8. So which one to replace among 6, 4, 7, 10? 6, 4, 7, 10, 6 has to be replaced, right? So 6 has been replaced by 8. Now 5, 5 is also not present. So in place of 5 should replace which one? 8, 4, 10, 7. So 7 has been replaced by 5. Now after that guys, this part is done. Again 8 is hit. Now 6 is there. So 6 should replace 8, 4, 5, 10. Which one? 8, 4, 5, 10. 10. 10 should be replaced. So 6 is here. Now again 8 is there which is hit. 8 is there which is hit. Then 11. 11 should replace 5, 6, 4, 8. Which one? 5, 6, 4, 8. So 4 has been replaced with 11. Now guys, 4 is there. 4 is not present. Again we need to replace some page. Which one? 11, 8, 6, 5. So 5 should be replaced by 4. Now the next is 9. 9 should replace 4, 11, 8, 6. So 4, 11, 8, 6. I believe 6 should be replaced. 6 should be replaced with 9. Now we have 5. So 9, 4, 11, 8. 8 should be replaced by 5. Again 9 is there, so 9 should be hit. I am marking it as tick. Then 6, 9, 12. Where is 6 guys? So 6 is not here. We need to replace among 9, 5, 4, 11. So 11 has been replaced by 6. This is 6. Again 9 is there, so 9 is hit again. Now 12 is there. So 12 is not present here. We need to replace from 9, 6, 5, 4. So 4 should replace this 12. 12 is present in place of 4. Again 4 comes. So from 12, 9, 6, 5. So 5, so 4 should be replaced by 5. Now 7, 7, 4, 12, 9, 6. So 4, 12, 9, 6. I believe 6 should be replaced by 7. Now 5. So from 7, 4, 12, 9. In place of 9, 5 is there. And then again 7. Now if we count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So 18. So C is the right answer. Now guys, next question, 133. 133. Which one of the following is correct with respect to short-term scheduling? The decision as to which available process will be executed by the processor. Yes, indeed. Right now, A, take it in your hand. B is not true because they are talking about I/O. The decision to add to the pool of process to be executed, C is also not true. D, the decision to add to the number, again they are talking about add part, right? Which has to be done from the longest term scheduler, not from the shortest term scheduler. So the right answer is A. Now guys, next question, 134. Which one of the following statement is correct with respect to bounded buffer in shared memory system? Now again, they are asking for bounded buffer part, which is nothing but producer-consumer problem. So producer-consumer problem, if you see option number C, the producer and consumer must be synchronized so that the consumer does not try to consume an item. And if you look at the option number B, they are saying the consumer must wait if the buffer is empty and the producer must wait if the buffer is full. Yes, this is the right option for the bounded buffer part. So option B is correct. Next, I think this is the last question from OS. Which one of the following is relevant to non-preemptive kernel? They are asking for non-preemptive kernel. Now if you look at option A, kernel allows a process to be preemptive, but they are asking for the non-preemptive, right? So A is not true. B, kernel data structure maintains a list of all open files in the system. This is not relevant to the question. If you look at C, kernel does not allow a process running in kernel mode to be preemptive. Yes, this is related to non-preemptive mode. A kernel mode process will run until it exits kernel mode blocks yield control of the CPU. So yes, I believe C is the right answer for this question. So guys, this is all about your OS part, and the next question will be take care from the next faculty. Thank you.
Right, I am here to discuss about material science questions in ESE 2023. There is a question here, which of the following is correct related to properties of good insulating material? So here, the properties are given in the question, options, different options are given. First option having high dielectric strength, low dissipation factor, and high operating temperature. So this is the property, the direct one, because here low dielectric strength is given in the second option. In the third option, high dissipation factor is given. Fourth option also low dissipation strength is given. So first option is the correct one for this question. The next question, which of the following statement is correct related to long range order in ferromagnets? For long range order in ferromagnets, 4 options are given. Okay, magnetic field of about 1 Tesla can be produced in annealed iron with an external field about 0.0002 T and a multiplication factor of external field factor. See, actually there is a formula that is actually the relationship between external field is equal to internal field into internal field plus gamma into internal field constant and m, right? This is the internal magnetic power and internal field constant, we can say. So by multiplying, internal field is not given, right? external field with external field factor by multiplying these two, like this one and this one by multiplying 1 terapascal you'll get. Here also by multiplying this one and this one you'll get 1 terapascal. So there is a chance of getting A and B both answers, but here it is not correct, here it is not correct. So either A or B is the correct one, or sometimes both. And next question, the Poisson's ratio for most materials. For most of the materials, Poisson's ratio is varying from 0.35 to 0.45, right? Direct, straightforward question. Another question, the intrinsic resistivity of germanium is 45 ohm centimeter. Direct, straightforward question. C is the answer for this question. And the last one, the Wien's displacement law. So Wien's displacement law states that the product of wavelength and temperature is equal to constant, right? And the graph, if you can see, right, the graph is like this, right? With the decreasing temperature, okay, this is going to change. Now, see here, lambda is proportional to 1 by T. From these options you can see, right, a definite minimum, and this minimum shift to longer wavelength as temperature decreases. Longer wavelength as a temperature decreases, right? Temperature, this is 500, right, 5000, this is 4500, like that, this is 4000, etc. A definite minimum, and this minimum shift to shorter wavelength as the temperature increases. Now see here, if temperature increases, wavelength decreases. So with increasing temperature, shorter the wavelengths are going to be. Here longer wavelength is given, so B is the straightforward direct answer for this. Based on this formula, you will get the answer. So B is the correct answer for this question, right? These are the questions related to material science.
Right. This is Ramesh. Now I am going to discuss the questions from measurements as well as basic electrical engineering. Two subjects I am going to take now. The first question here is relative static error formula. This is a straight away formula. Relative static error is equal to AM minus AT by AT. If you want to take percentage, that is in 200. If you see the formula directly, absolute error by true value is the answer. Absolute error by true value. Why? This is called as absolute error by true value. So straight away option C is the answer. Right. Next question is, in order to eliminate the effect of temperature variations upon length of the spring. Sir, in the instrument we are using two springs. In order to eliminate the effect of temperature variations, we are going to take the two springs in the opposite direction. So straight away, two springs coiled in opposite directions are used. So straight away answer option A. And next question is, one of the advantages of Arrington shunt that it eliminates the possibility of the meter movement being in the circuit. Right? The advantage of Arrington shunt system itself is without any shunt resistance. This is straight away answer. Right? Next one is, in a rosette gauge, the angle between any two longitudinal gauge axes. Generally, two types of rosette gauges will be there. One is rectangular, other one is normal. In that 45 degrees and 90 degrees will be there. So among the options, only one is there. So straight away, 45 degrees is the answer. Right. Next one. This is generally confusing one. Right. Here, I is given as 25 ampere and dm by d theta is given. dm by d theta is given as 0.0035 millihenry per radian is given. Right? Now, After that, Kc is also given 10 power minus 6 Newton meter per radian. Right. Here I am giving just half a minute of a solution because according to the procedure, no option is matching in this question. So that is the reason I am taking theta is equal to I square by Kc dm by d theta is a straight away answer. If you substitute all the values I square dm by or I square by Kc dm by d theta, you will be getting around 2100 plus etc. But the theta will not be in that much larger value. So according to the given data, the answer will be 2000 approximately is a 2100 something. But in the options, no answer is there, no 2000 plus. So therefore, logically, for an electrodynamic dynamometer ammeter, what is the possible scale range? The possible scale range is maximum of 130 or 140 degrees. So according to that answer, simply straight away we can say that option D is the answer, 125. I repeat, according to the given data, answer will be 2000 change, but none of the above. But the meaning of the question, logically we can answer electrodynamometer instrument, the scale itself is around 130 to 140 or maximum 130 to 140. Therefore, among the options, 125 is the suitable answer. Right? Next. Right. Now I am taking missions questions, BWE questions we can say. A 100 kVA 50 Hz single phase transformer has a ratio of secondary to primary turns. Straight away answer N2 by N1 is given as 0.1. The secondary voltage, so V2 is given, or we can say E2 is given. How much? 100 volt. He is asking primary voltage. So therefore straight away V2 by V1 is equal to N2 by N1. If you simplify this, you will be getting V1 as the 1000 volt. So straight away answer here is yes, option C. Right? Next question. A 230 volt DC shunt machine. It is somewhat numerical value based. So RA is given. Armature resistance RA is given as 0.5. Field resistance RSH is given as 115 ohm. And he has given as load current IL is equal to 50 ampere. And V is given as 230 volt. What he is asking, right? Find out the corresponding generated EMF in both the cases, generator and motor. Very simple. In the case of generator, EG is equal to V plus IARA, and in the motor case, EB equal to V minus IARA. I am giving the straight away answer. Anyway, elaborated, discussed, right? Elaborated answers or solution will be there in the website. But I am giving, if you substitute these values, you will be getting 256 volt and 206 volt. All values are almost given. So therefore, option A is the answer. Right. Next question. A 4-pole, right? 4-pole P is equal to 4 and frequency is given as 50 Hertz. And the full load speed NR is given as 1455 RPM. Right. What he is asking? Simply he is asking slip as well as rotor current frequency. From this we can calculate NS 120 F by P. Right? Frequency 50, poles 4 means you will be getting 1500 RPM. And S is equal to NS minus NR by NS. If you simplify this, you will be getting 0.03. After that, FR is equal to S into F, 0.03 into 50. You will be getting 1.5 Hertz. But if you see the options, again somewhat confusing number. He has given that 0.03, 0.03, but is 15 and 50 is given. Actually, it is supposed to be 1.5 because the FR cannot be 15 or 20. FR is always 1.5 to 2.5 will be there. So straight away, option A. Right? Next question. This is a question. The pressurized water reactor is similar to a boiling water reactor except that the cooling water is pumped through the reactor under. Nothing but it is with respect to pressurized water reactor with respect to the other reactor. The straight away answer is it is with respect to only difference is high pressure. So these are the questions from the measurements as well as basic electrical engineering.
Hi everyone. So anyway, now you know which subject is pending. So the last but not the least, electromagnetic theory. So let's get into our solutions of this electromagnetic theory. Anyway, here I am not here for making any class or elaborate lecture, but before going into this, I want to make one point. Here the thing is this, in this session, I think we got around 20 questions. If you really look into these 20 questions, so here all these 20 questions are based on these things. One is this Maxwell equation, the other one is about the materials, means conductor and dielectric, the other one is going to be the matching, and the final one is going to be the directivity. So this is how we are always urging the students to look any subject. Okay, without delaying, so let's get into this. So here, if you look this first question, this is about vector potential is a vector, and they given some couple of options. As I said, most of our questions are based on these topics. So now this question belongs to this Maxwell equation. As you know, aware of one of our Maxwell equation. So one Maxwell equation, you might aware the standard case. One is this del cross E equal to 0. The other one is going to be del dot B equal to 0. As you know, this del cross E equal to 0, which is named as irrotational vector. And this is divergenceless vector, or the technical name is solenoidal vector. So this is solenoidal vector. Yeah. So this is solenoidal vector. Okay. So as this is solenoidal, here you know, based on this, you have some standard vector identity. Whenever you have rotational vectors, they are written as gradient of some scalar potential. Whereas this solenoidal divergenceless, where it is written as curl of vector potential. Okay. So now this itself gives. So this is associated with the vector potential is a vector. Now you can see here whose curl is equal to the magnetic flux density. Why? Because this is nothing but divergenceless flux density is our magnetic case, and here this is associated with this, right? So B, which is our magnetic flux density. So here the option is going to be A, right? Right. Now get into this second question. So again, as I said, so based on our Maxwell equation, just now we did for solenoidal field, B is going to be what? B is going to be del cross of A, right? So as we are here interested, they given vector potential and they are asking what is the magnetic flux. So you know, here if you take open surface integral on both sides, you know this is nothing but is the flux through the open surface. So which is equivalent of del cross A over this given surface. So here what is the thing we need to do? So we need to solve this curl, but here this curl is associated with your which coordinate system? Cylindrical coordinate system. So here we have to take this curl in cylindrical, and I think if you solve that, you would get this curl is going to be in phi direction. So you needed this area is also in phi direction, and if you simplify this, then you would get this as the answer. Right here? Okay. So again, as I said, so this is vector. Now they are asking about given something, some vector, and they are asking about irrotational and solenoidal. Irrotational and solenoidal are both are associated with what? Curl and divergence. So that makes what? The only thing what you need to do is you solve what is the divergence of this vector, and you need to solve what is the curl of this vector. And if you substitute in this and if you solve, here this is not going to be 0, this also not going to be 0. As I said just now, this divergence is not equal to 0, right? So this is going to be non-solenoidal, right? So or not solenoidal, then this is going to be the curl not equal to 0, so which is going to be irrotational. So based on that, what you have here, it is irrotational, P is both solenoidal, P is solenoidal, neither solenoidal nor irrotational. So here this makes that option, right? Okay. So as I said, so here this if you look, it is associated with your conductor. Associated with the conductor, all of you guys know the electric field associated with the conductor. So electric field always exists normal to the conductor. So and that electric field which is going to be nothing but rho s by epsilon times of some normal vector. But here we are interested only the magnitude of this surface charge density, surface charge density. So surface charge density is nothing but epsilon times of electric field. So this is nothing but they already given epsilon, 80 epsilon naught, and they given the electric field. Substitute in this, I think you would get this as going to be the answer. Okay, same. Now this is associated with your electric field, and you are interested in finding the potential. As you are interested in finding the potential, so what is the potential? Potential is nothing but work done. What is the work done? Work done is nothing but force dot dl. Potential is work done per unit charge. Work done per unit charge against the field or force, right? Then if you integrate, you would get this corresponding potential. As you know, this is nothing but E dot dl. So some initial location to some final location, they given everything. And you substitute in this, I think you would get that as an answer. Right. So now this is going to be associated with the directivity. So all of you guys remember the standard equation of this directivity, which is nothing but 4 pi times of maximum value of intensity by which is nothing but the radiated power, right? So here maximum value of intensity is going to be 1, and I think you might remember the radiated power. Radiated power is nothing but, so this is the field vector magnitude, this field vector squared, and this is integrated over the omega. Okay, now here this omega is what? This is associated with the solid angle. So this is going to be the sine theta, d theta, d phi, and here your squared. So this is going to be some cos of 8 theta, something like this you have, and here your theta is ranging from 0 to pi by 2, and here this is your 2 pi. So here if you simplify this, I think you would get this B as an answer. The previous question. Here I want to make one note. I think if you look this similar, or I think the same question is once given in GATE exam. So here anyway, for this given question you don't have any ambiguity, but if you are referring further, here it is not necessary that it is always going to be a field. Why? Because he didn't mention anything here in this. They given it is only explicitly function of theta, only function of angle. It could be your intensity also. But in this, based on here given options, we don't have any ambiguity. But if you look one of our previous GATE question, there they created the ambiguity. So when you are further referring, you always make sure of that. Once if it is given, it is not necessary that it is always going to be a field. It could be radiation intensity also. Right? Make note of this. Okay. Now, so again, so this also associated with your directivity. Just now I think I given the equation of that directivity. So the directivity is nothing but 4 pi times of maximum of intensity, and here I written it as going to be the radiated power, but this you could also write it as going to be the maximum intensity to average radiated power, or similar to that. You can write this is average radiation intensity. Okay. So this could be average radiation intensity. So what I am suggesting is direct equation. So here this equation is going to be the C, average radiation intensity. But again here I want to make a note. I think majority of us, we will choose this option. It's okay, it's correct option. But the thing is, if you really check this A option also, if you look this A option also, so here he is saying the concentration of radiated power in a particular direction. So as he said, it is going to be the concentration. As he said, it is going to be concentration means. So he is actually saying the definition of the directivity. What is directivity? The ability to concentrate the radiation in a specific direction. Once they said concentration means, whether they mentioned with respect to isotropic or not, that is already inherently there. Concentration means it is with respect to isotropic only. So that makes here this option can also be correct. Anyway, this is straightforward. But here if you look the actual definition of the directivity, this could also be the option. Right? Okay. Now coming to the, this is your elementary physics. So the energy stored in this capacitor. So I need not to take your time. So this is straight away the answer. Right. So now coming to this your dipole question. So again, this is nothing but sum of dipole moments of individual. As you know, the potential because of one element, so which is going to be the dipole moment by 4 pi r cube you would get. Now here you are interested in the resultant potential because of the two dipoles. So then this could be V1 plus V2. Then this is going to be R1 cube, and this is P1 plus something like that you will get. Anyway, just substitute and simplify. I think you would get this answer as this one here. Now here you have to be little bit careful in this. Anyway, in this if you look, he is asking based on again Maxwell equation question. Again Maxwell equation question. Here the thing is, this sigma and the epsilon, they are permittivity or property of the material. Del is what? Del is, I am writing in general I am writing, this del is space derivative operator. Space derivative vector operator. Vector operator. What does it mean? That means this vector space operator, it is function of direction as well as the space. Right? That makes what? If you are writing this sigma as well as this epsilon outside of this vector differential operator means these things, they should be independent of space as well as the direction. Independent of space gives the character of homogeneous. Independent of direction gives character of what? Isotropic. So that makes here the option is going to be C. Right? Again, just please. So the thing is, here in this B option also you have homogeneous along with the linear. So linear is only if you speak in terms of this manner. J is equal to sigma E and you have this D equal to epsilon E. Here in this the relation between the source and the effect. Relation between the source and the effect means this J to E, this is sigma, D to E, this is epsilon. So E is the source, J and D are the effects. So now the interrelation between the source and effect is maintained as a constant or linearly dependent. So what does it mean? Here if you don't have this space derivative, if they given something like this, you could have chosen this linear, but here they given the vector space derivative. That's why in this isotropic character is the one which is appropriate conceptually also, right? Okay, and again I need not to mention anything about this, so it is standard. Right, so again this also straightforward. You know your magnetic field is transverse. Your magnetic field is transverse, so that makes what? Okay, so now this, if you look into this, here he speaks about the matching. He speaks about the matching. So whenever your impedance is going to be not equal to characteristic impedance, there you go for the impedance matching. So the one of the impedance matching is this first option is associated with the single stub matching. So single stub matching, you know, the basic limitation of the single stub matching is what? That single stub matching is only for a specific load. If load got changed, then you have to change location of the stub as well as the length of the stub. This is the drawback of the single stub matching. In order to overcome this, you generally go for what? Double stub matching. Where the double stub matching, you need not to change the locations of the stub. If your load is going to be changing, only you can adjust the length of the stub without changing its location, you can realize that matching. This is what is given by this first statement and the third statement. And you know, wherever you find these open wire transmission lines, you always go for the short circuited stub. The reason of going for the short circuited stub itself they provide the low radiation loss, right? So now here 1, 2, 3 they are correct. Now what about the last one? The last one itself, here they are mentioning you are operating at high frequency. So at high frequency there is no question of having this lumped nature. So that's why you need not to even think about that option. Straight away you can ignore that. So 1, 2, 3 are going to be the right. So that makes, I think, here 1, 2, 3. Okay. So now this also, what is this here? This is about the displacement current. So I think I need not to mention, I think all of you remember this equation. So they are talking about magnitude of this. So as you know, this is your JD, which is j omega epsilon E. So as you are looking for only the magnitude, omega epsilon E, E is, as you know, V by D. Everything you have there, substitute in that. I think you would get this as the answer. Okay, so this again substitution based question. So here for this you use that equation which is 60 times of under root of mu r by epsilon r log of b by a, you would get. And here they given diameter, but both are given diameter, inner and outer diameter. So both numerator and denominator 1 by 2, 1 by 2. So you can write this one, substitute and simplify this. I think you would get this as 16 ohms. Okay, so related to the electromagnetic wave. So here the key point in this is this. This is in free space. So once if it is going to be in free space, all of you know this is nothing but your beta. Beta in free space. Beta in free space is what? Beta in free space is nothing but omega by c. So your omega is nothing but beta c. So from this you could get your frequency. Okay, and here the other thing is, you know about this polarization. This polarization is, they are having phase difference of 90 degrees, amplitudes of same. So you know this is case for your circular polarization. So if you check this, this would be that. Okay. Now coming to this, so you know if it is going to be wave equation, so it should be linear function of space as well as time. This should be linear function of space as well as time. If you look, as you know, these two are propagating waves. This is going to be the standing wave. No, forget about the nature of the wave. If you look basic mathematical, so these are linear function of space and time, but here it is going to be the non-linear function. So here this is not going to be the answer. Remaining would satisfy. Okay, fine. Now coming to this, so the at high frequency. So at high frequency, now you know. So here your at high frequency skin depth or skin effect come into picture. So now the impedance of this, you would get something RS plus JXS kind of thing. So that makes it is associated with the positive reactance. I am not writing the complete equation. So here positive reactance means obviously this is associated with the inductive nature. So this would be this. Okay. Now the depth of the penetration, here the key point is this. The key point is he speaks not about the general way, he is specific about a particular medium. But here you know the depth of penetration, skin depth it is always reciprocal of alpha. But here you are talking about attenuation of the lossy dielectric medium. Attenuation of the lossy dielectric medium, this is sigma by 2 under root of mu by epsilon. Now if you take the reciprocal of that, so this would be 2 by sigma under root of mu by epsilon, what is that here? Not this one. So this is 2 by sigma under root of epsilon by mu you would get, right? So based on this, if you check, so depth is going to be increasing with respect to the epsilon in the given options if you look, right? Here you don't have the problem with the conductivity and permeability because they are inversely related. But for few, you might have the problem with this wavelength. You know, wavelength, here if you specifically look into this, for this lossy dielectric material, the attenuation constant, it is not at all depending on the wavelength, right? So here are the frequency. So this is at a specific given frequency, this material having so and so behavior. But the point here is this. The point here is, if you look for your conductor, there you would find this is going to be something like this. You would find something like this. So you could say this is going to be related this manner. Now as your lambda is increasing, depth is going to be increasing. But the point here is, this is going to be strictly for conductor. Here what is his intention? His intention is of this material. So that makes here the appropriate is going to be that permittivity. Fine? Next one here. Which of the following can propagate in a conducting? Just now as I said, skin depth. Skin depth is associated with the attenuation or the loss of the signal as it is penetrating into that. So obviously it is associated with the depth. Now anyway, if you look this one also, here copper behaves as whatever it may be, the basic significance of our field theory is this. The electrical character of the any particular material, it is not depending on their material characteristics or material parameters, it is completely dictated by at which frequency you are operating, right? That answer I given. That makes what, whether, how, which kind of material it is going to be behaving, so that is strictly depending on frequency. You know, just adding one more point. When you come across your electronics, there you mentioned that BJT or some circuits, you mentioned high frequency equivalent circuit, low frequency circuits. Why you are saying that this electrical behavior of the material is going to be changing based on at which frequency you are operating, right? So based on that, this is the suitable answer. Okay, so this is your standard equation. So which is going to be which one? This is going to be the distortionless line. So you know, here you have a distortionless condition and you have this alpha in this, which is going to be RG. So use that distortionless condition and you substitute in this, I think you would get this as the answer. Okay, okay, before finishing this, our review question, review session from our ESE Academy. So I am taking liberty to saying one word behalf of our institute. You know, success rate in this exam may be single digit, or maybe hardly 10% or 15%. Maybe you guys are going to be cleared. But I want to tell you behalf of our institute, you tried for one of the dream job for every engineer. If you not succeeded, don't disappoint. Because your whole almost, as you completed your graduation means, so it is your journey of your 17 to 18 years. This much of your long journey, don't give up for 1 or 2 years. Whatever the others may be think of, don't give up. You keep on striving for this, because as I said, this is dream job for most of the engineering graduates. So in that journey, whichever the way you are looking for, we are ready to help you. Okay, good night. Anyway, again, congrats. Thank you.